Good morning. Today we will review the concept of complementation. Firstly, we will discuss complementation and then elaborate on the concept with the help of a simple non-biological example. So, why is complementation done? Complementation is used to determine if two mutants fall in the same gene or they fall on different genes. For example, in this, both the mutations have lysine biogenesis pathway defects, and this could be on the same gene or different genes. But they cannot produce lysine on their own. So, to determine what kind of mutation it is, we simply make a cross between these two strains. And if they can grow, it means that the mutation is on different genes and one strain can complement for the other one. However, if they cannot grow, that means that they are on the same gene and therefore complementation does not take place. So, in order to elaborate on the concept, let me give you a simple non-biological example, such as the knitting pathway to speak of. It's fairly simple and straightforward. In order to knit, you need two things, needles and wool. Now, in this demonstration, if we have a ball of wool, I cannot knit on my own because I am lacking needles, as if to say that there is a mutation in the gene for the needles. It is equivalent to that. So I cannot knit. On the other hand, if I have only a pair of needles, it is the same thing, because this time I'm lacking wool, or there is a mutation in the gene of the wool, I cannot knit either. However, if I have one strain which has wool, no needles, and the other strain which has needles but no wool, we can cross these. They can come together, work as a team, share resources, and if we have both of these things, we can knit a nice sweater. That is complementation. When the mutation are on different genes, two strains can come together and produce viable progeny. However, in the case of non-complementation, if we have two pairs of needles, again the strains can come together, but the mutation is the same, lack of wool. So even though they can work together as a team, they can share their resources, we will not get a viable progeny. Same thing again. If we have two balls of wool and no needles, we cannot knit a sweater. Only if the mutations are different genes, we can get viable progeny. So complementation tests is very important to, again, find out if the mutation is on the same gene or on different genes on two different strains. Again, complementation test is a major part of Benza's work. ये आपके कोर्स में था, आपने पढ़ा होगा, ये इंटरजीनिक क्रॉसिंग ओवर का एग्जाम्पल है. Benza's वर्क था इंट्राजीनिक, ये है इंटरजीनिक. याद रखिए, ये आपके बेंजा के वर्क के पहले आपको बताना पड़ेगा. ये है complementation test. Thank you very much. That's all for today.